We discussed earlier in class how to solve a system of equations in 3 variables, which increases the difficulty of a system of equations in 2 variables. This one was particularly challenging because if you recall the other equations, not all variables were present in all the equations, so they weren't all stuck together like they are in this one. As you can see, each of these equations has all 3 variables linked together in it, so it's going to take a while to untangle all of this, but you have to be patient, you have to persevere, and you know, let's see maybe how we can get started. Let's try to think about chopping this down to where maybe we've only got 2 variables, because we can solve a system of equation in 2 variables much easier. So I'm going to pick one variable that I want to just eliminate, and just by sizing things up here, it looks like y might be a good variable to eliminate, and I think you'll see why when we get going here. So I'm going to start here by saying I'm just going to concentrate on 2 variables at one time. I'm just going to look at, well, let's just write it off to the side. I'm going to look at these first 2. So I'm just going to rewrite 2x minus y plus 2z equals 15, and negative x plus y plus z is equal to 3. And by using the elimination method, you'll notice that the y's will cancel out. I don't even have to do any multiplication whatsoever. The y's are just going to cancel out when I add, using this really sweet method. And I've got x plus, well, the 0y, plus 3z. 2z and 1z is 3z, is equal to 18. Sweet. And I'm just going to leave that as is for a second. And I'm going to go ahead and, remember that was the first 2 equations here. And I'm going to do the exact same process using 2 other equations. Now let's choose some Christmas colors here. I'm going to use 2 other equations. I'm going to choose equation number 2 and equation number 3. And try to get the y to cancel out of those ones as well. So if I have, I'm just going to rewrite it, negative x plus y plus z is equal to 3, and 3x minus y plus 2z is equal to 18. And again, we want to get the same variable to cancel out. That way we have a system of equations in 2 variables. So again, the y's, we want to get the y's to cancel out, and it works out nicely that their coefficients are already additive inverses of each other, 1 and negative 1. When you add, you get negative 1x and 3x, leaves us with 2 x's. The y's disappear to 0y, and I believe that leaves me with 3z is equal to 21. And by doing this elimination process, I'm now left with 2 equations that only relate x to z. Sweet. So now what? Well, now I'm going to use those 2 equations. I'm going to say that one and that one are going to be vitally important. So I'm going to use 2x plus 3z equals 21. And the top one up here, x plus 3z is equal to 18. So you might be wondering which variable you want to solve for here. Well, nothing cancels out because coefficients are not additive inverses of each other, so we can make that happen simply by multiplying one whole equation by negative 1. If you want to get the z's to cancel out, that'd be really easy. So multiplying by negative 1 just changes the sign of all these, and pretty easily we can just add down now, leaving us with 1x. Z's disappear, is equal to 3. Oh wow, hey, x is equal to 3. Sweet. So I think we're done now here, right? Oh wait, no, we're not done. I still don't know what y equals, and I still don't know what z equals. But I have equations up here that show the relationship between x and z, and I've got some that show the relationship between x, y, and z. So I'm going to work backwards. I'm just going to choose one of these. I don't know, maybe I'll choose this one. Choose this first one that relates x and z. So I'm going to come back up here to this one. I'm going to go with x plus 3z is equal to 18. And by substitution, I'm going to replace that x with 3, because I know x is equal to 3. By substitution, I know that I've got 3 plus 3z is equal to 18. Now I can just solve for z by subtracting 3 from each side. We've got 3z is equal to 15. Divide both sides by 3. And z is equal to, you guessed it, 5. Right on. Almost done. Almost done. I'm going to come back up to one of these top equations now, where x, y, and z are all related to each other. And you can choose any of those top 3 equations and use the substitution again. We can do this by substitution. I'm going to choose the one where I don't have to do any multiplication. This middle one here is nice. Negative x plus y plus z is equal to 3. No coefficients. X is 3, so by substitution again, I'm going to have negative 3. Still don't know why. Gonna leave it y, solve for it. Z is 5. Is equal to 3. By combining like terms, 5 and negative 3 should be 2. And now all I gotta do is subtract 2 from each side to find the final solution here, that y is equal to 1. If you recall, when we talked about system of equations in 2 variables, our answer could be represented as an ordered pair, an xy ordered pair. In a system of equations with 3 variables, where you have 3 unknowns and 3 equations, you can represent your answer as an ordered triplet. 3, 1, 5 indicates x is 3, y is 1, and z is 5. Was this a lot of work? Yeah. Yeah. Is it nice and colorful? Yeah. Yeah. I would encourage you to do the same type of thing in your own work. Maybe use different colors, help separate your work, so that way you can show where you're doing one part of the problem, and you move on to another part of the problem. Makes it look really nice. Oh hey, I almost forgot to mention, make sure that you practice this skill now by looking in your textbook on page 142. You'll have some time in class tomorrow to do some of these. And also all those things on the wall, all those things over there on the wall, you'll have some time to work on some of our matrix operations in class.